Hi everyone, welcome to your video lesson for Unit 3.2. Today we're going to be talking about parallel and perpendicular lines and writing their equations. So we're going to be using a lot of our skills from 3.1 and we're going to be mixing in, some understanding of parallel and perpendicular lines. So the first thing that we need to know are about the slope of parallel lines. Okay, so parallel lines are always going to have the same slope because they are never going to intersect. Okay, so we see that these are running in the same direction and they are always the same distance apart. So the only way that that can happen is if they have the exact same slope. Now we can see that their y-intercepts are different, okay, but that does not affect the slope. Now, if we wanted to determine whether or not two lines were parallel, or in a couple minutes, if two lines are perpendicular, all we have to do is compare the slopes. All right, so for parallel, we're looking, are these the same? So in my first equation, okay, this is already in y equals mx plus b. So I can see that my slope is -1/3. In my second equation, this is not slope-intercept form, which means I need to solve for y. Okay, but we've been doing that for quite a while now. Okay, and we know how to solve for y. Okay, we move the x and we divide. Okay, so comparing the slopes, the slope of this line is also -1/3. So that means yes, these are parallel. Okay, now perpendicular lines follow a different rule. Okay, so perpendicular lines are going to intersect at a 90-degree angle. Okay, and the relationship between their slopes is something called opposite reciprocal. So opposite refers to the sign. So one of them is always going to be positive and one is going to be negative. And the reciprocal, we know, means to flip the numerator and the denominator of a fraction. So let's take a look at some slopes here and see if we can't figure out the perpendicular. Okay, so if the original slope is 3/2, the perpendicular slope, and that's just the symbol for perpendicular, okay, if this is a positive, my perpendicular slope should be negative, and the reciprocal is 2/3. Okay, so if I graphed a line with a slope of 3/2 and a slope of -2/3, they would intersect at a 90-degree angle. Okay, in example 2, the original slope here is 5 because this is already in y equals mx plus b. Okay, so to make my perpendicular slope, we're going to flip the sign. We're going to do the opposite, so it should be a negative. Now, in order to make this a reciprocal, I can put my original over 1. So my perpendicular slope should be a -1/5. Okay, now in the third line, I cannot determine the slope if it's not in y equals mx plus b. Okay, so I'm going to take that equation and I'm going to solve for y. Okay, I know how to do that. We've been doing it for a while now. So we're going to move the x and divide. Okay, so this is still the original equation. Okay, so that means my original slope is 1/3 and my perpendicular slope is going to be -3. Okay, so finding the perpendicular slope is really very easy. You just have to make sure that the equation is in the right form. Has to be in slope-intercept form. Now, in order to write equations of parallel and perpendicular lines, it's going to be very, very similar to what we were doing in 3.1. Okay, you're going to be given a line this time. You're going to be given the equation of a line rather than the slope and an ordered pair. Okay, and you're going to be told whether or not it's parallel or perpendicular. So from that given line, you'll then have to apply the rule for parallel or the rule for perpendicular to determine what slope you're using. Once you get the slope you need, you do not use the equation of the line any further. Okay, you will then be given an additional ordered pair, and that's what you will use as your x and y value so that you solve for a brand new y-intercept. So you should always be solving for b when you're writing the equation of a line. We saw that in 3.1. It's going to be the same thing for parallel and perpendicular. So let's take a look. So we're writing the equation of a line that goes through 2, -8. So we know that's an x and a y value. And it's parallel to this line. Well, the only thing I need from this line is the slope. So the slope that we're given is 3. I need a parallel slope. So that's the symbol for parallel. So parallel slope is the same. Okay, once I get my parallel slope, I'm going to cross out that line, the equation, because I no longer need that. I have all of the information that I need now. I have a slope and I have an x and a y value. I'm going to plug those in to y equals mx plus b. Okay, and we see I'm solving for a brand new b value. So I'm going to use b, and I'm going to use my new slope, the parallel slope, to write my final equation. Okay, and just like in 3.1, when we write the equation of a line, we leave x and y as variables. Okay, let's try that again with a perpendicular. So write the equation of a line that passes through 5, 1. So an ordered pair is always my x and y. And here's the equation that they're giving me. So the original slope is 5. And I'm looking for a perpendicular line, which means I need a slope of -1/5. Once I find that, I want to cross out everything else. Okay, so that I make sure I do not use the wrong information when I solve. Okay, so plug in all of my information, and I'm going to solve for b. Make sure that for your final answer, you actually write the equation and you don't just leave it at b equals 2. Okay, you want to make sure that you're plugging the correct slope into your equation. So the slope in your final answer should match the slope that you used to solve. Okay, if they do not, you need to go back through your work. Okay, so here's another perpendicular, because this one can be a little bit confusing. Okay, so I'm given, whoops. So there's my ordered pair. So that's my x and my y value. Okay, my original slope is -1/3. And since I want a perpendicular line, perpendicular slope is going to be +3. Okay, so again, once I get that, I'm crossing everything else out. So I make sure that I don't use that. Okay, I'm going to plug into y equals mx plus b and solve for the y-intercept of this new line. Okay, and my final answer. Make sure you're using the correct slope. I cannot stress that enough. Okay, and plug in your y-intercept. Alright, so this is asking for a parallel line, but it says 2x minus 3y equals 10. And what can we tell about that line? What can we tell about this equation? It's not slope-intercept form, which means you cannot get the slope, which means we don't know what the parallel slope is going to be until I solve this equation for y. So move the x and divide. Okay, now my y-intercept is a fraction, okay, but that doesn't matter because the only thing that we take from that equation is the slope. Okay, so the slope there is 2/3. I'm looking for a parallel slope. Okay, so a parallel slope is going to be the same, which is 2/3. And then I'm going to cross out all of that information because I don't use it anymore and I don't want to get confused. So now I'm going to use the ordered pair that was provided and the slope that I just found. And I'm going to solve. Okay, so now I'm trying to add fractions here. So I would have to make a common denominator if I'm doing this by hand. If you're doing it in your calculator, you can just plug it in. But this is equivalent to 9/3. Okay, so when I add these together, I can just add across the top. But we get 25/3. And we do want to leave this as a fraction because the decimal is going to be repeating and would not be exact. And since we're writing the equation of a line, we need that to be the exact value. Okay, so now we're going to take our parallel slope and our y-intercept and plug them in for a final answer. Okay. We have two more problems, and they both happen to be special cases. So we know that our special cases typically involve horizontal and vertical lines. Okay, so write the equation of a line that's parallel to x equals 3. There we go, that's a special case line, and passes through the point of negative 9, 5. All right, so there's going to be a lot of thinking and not necessarily a lot of math in these special case problems. Okay, so x equals 3 is a vertical line. So we need to know the slope of a vertical line. Okay, so if you have to draw yourself an example, okay, if you want to graph x equals 3, or if we just have this memorized, a vertical line has an undefined slope. Okay, so in order to be parallel to that, would also be undefined. Okay, which means it's going to have the same equation set up as the one that we started with. So in order to be parallel to a vertical line, you have to be another vertical line. So we are looking for something that is x equals a number. Well, in the ordered pair that we were given, what is our x value? Okay, so x equals negative 9 is our final answer. Now, you could also solve this using a picture. Okay, so here's a graph for x equals 3, and the point here's negative 9, 5 that they gave me. So if I need it to be parallel to x equals 3, it has to run in the same direction. So what value does that line go through? It goes through negative 9. Okay, so that's another way, using a picture, that you could solve that problem. Okay, so here's one more. So find the equation that is perpendicular to y equals negative 2. Well, so we could look at, pretend that went through. This is the graph, okay, of y equals negative 2. So this is a horizontal line. So we need to remember the horizontal line has a slope of 0. Okay, so perpendicular slope to that would be undefined. Okay, because let's say, for instance, you were solving for the slope. In order to get 0, you would have 0 over any number. Okay, in order to make that perpendicular, okay, obviously you would flip the sign and you would have any number you could think of with 0 on the bottom. Okay, well, it doesn't matter that there's a negative in front of that. 0 on the bottom is always undefined. Okay, so 0 and undefined go together. They are perpendicular slopes of each other. So now I know that I'm looking for an undefined slope. Okay, I need to know, well, what kind of line has an undefined slope? That's a vertical line, which we just saw is x equals a number. Okay, you could also think, how would you be perpendicular? How could you form a right angle with a horizontal line? Okay, and the only way to do that is with a vertical line. So what x value is this ordered pair telling me to go through? Okay, this line has to go through x equals 1 in order to be perpendicular to y equals negative 2. Okay, so those are all of the situations that you could encounter for parallel and perpendicular lines. Please make sure that after you find the parallel or the perpendicular slope that you are crossing out the original equation that you are given so that you make sure to solve for a new b value. Okay, so make sure that all of your notes are complete. You write down any questions that you have, and I will see you next time. Thank you for watching.